This video is going to demonstrate how to produce a two-view sectioned orthographic drawing from an isometric starter. This is to simulate how a drawing might be in a HSC Engineering Studies exam. I'll put a link to the file that has this diagram on it in the description of the video. Okay, the equipment I'm going to use, a couple of set squares, although for this drawing you could pretty much get away with just the 45-degree set square. I've got a couple of mechanical pencils. I've got a 0.5 and a 0.7 millimeter, although you really only need the 0.5. Compass with a nice sharp lead and an eraser. Alright, since we don't have a drawing board and T-square in the exam, I'm going to start by drawing myself a baseline that I'm going to use as a reference for all my horizontal and vertical lines in the drawing. That should be a nice light construction line. And I'll start by doing a vertical line at the right hand side of the page, which will be where I'm going to start drawing the front view of this object. Okay, so the task requires us to do the front view and a sectioned left end view. Let's work out the height and width of this object before we begin. So the width. Easily you can see the 75 millimeters here. You can see a 25 millimeter radius here, which means 25 from there to there. And we can see that this circular feature here is 75 millimeters in diameter. So that would be 37.5 millimeters from this center line. By the way, this center line continues through this center of the circle there. So 37.5 from there to the outer edge. So we've got our 37.5 plus the 75 plus the 25 gives us 137.5. So the height. We have this 25 millimeter radius. So from there to there is 25. From there to the top surface here you can see 32. This flange is 16 millimeters thick around that center line, so I'll add another 8 millimeters to that to bring us down to the center line. And then again we're going to use half of the diameter of this circular feature, 37.5 from there down to the bottom. 25, 32, 8 plus 37.5 gives us 102.5. Right, so 137.5 I'm going to measure from that starting point on the right hand side. Place a mark on that measurement over here. And then use that to put in a vertical line. Now the height, 102.5. I'm going to measure that at 2 points here, 2 points up from the baseline, rather than relying on the 90 degrees from the set square, just to help reduce cumulative error a little bit. So I'm going to project that line all the way across the page because we'll need it over here when we do the left end view. Okay, so we're going to start by putting in this large circular feature here. It's a 75 millimeter diameter. So set your compass to half of that diameter, so that would be 37.5 millimeters. Got my compass set to the right size. So now to position the center of that circle, I'm going to take that radius and lay it out on the horizontal and the vertical sides of the rectangle. Then from those points, I'm going to scribe a couple of arcs vertically and horizontally from that point. So that should give me the center of that circle. So now I'll draw that circle in. Just draw it in lightly for the moment because we might need to add something or change something. Now the next circular feature here is 50 millimeters in diameter. So I will set my compass to 25 millimeter radius. Now this circle I'm going to draw in full weight off right from the beginning because I can tell by looking at the drawing that I won't need to add or remove any sections of it. That circle is going to be a complete circle in the final view. Okay. So next thing I'll do, don't mind the baby noise, is a horizontal center line all the way through that part and all the way through the other view. So I'm going to again do a 37.5mm mark up from the baseline, and I will project that line right through. Now at some point this will have to be drawn as a dashed center line, but for now that'll do. Right, the next thing I'm going to draw in will be this arc here, this 65mm radius arc that's the top left corner of this part. So I'll set the compass to 65mm. uh, 65mm. Right. Now I can measure along this center line that I've just drawn, put a little mark there, and that is the starting point for that arc. And this is a way to check yourself, because the end of this arc should form a tangent to that top edge of the rectangle. If it doesn't, you've been inaccurate somewhere. Alright, so let's do the arc over in this top right hand corner now. So that's, as you can see, a 25mm radius, and conveniently that 25mm radius is concentric with this circle, which means we don't have, once we locate the center of that, we've located that center for two features. So grab that 25mm radius. And do the same thing again to find the center. I will make a little mark on the horizontal and vertical sides of the rectangle, and then from those points draw two new arcs, and at the point where those arcs intersect I will draw in the arc in the top corner. While we're at it, I may as well draw the circle. It's a 22mm diameter. So I'll set the radius of my compass to 11mm. Draw that in. Okay. Now we'll draw in the upper and lower surfaces, or the edges, of that horizontal flange. You can see it's 16mm high, so 8mm above and below that center line. And I'll do the same thing over the left hand side of the page, because we'll probably use that later. Light lines. Alright. So now we know that those will be full weight lines from the edge of that 75mm circle all the way across to the right hand side of the rectangle that we drew at the beginning. Now that's basically that view mostly complete. I'm just going to firm in a few of the remaining lines, darken them up a bit. Now I'll come back and finish off this 75mm circle. Now the only other things that we need to do on this view, we need to draw the hidden detail to represent this hole that goes through that part, or through that horizontal flange, and we can see that's a 20mm diameter, and conveniently its center is also 25mm from the edge. So may as well draw a center line at the same time. So I'll strike a vertical line through the center of that circle that we drew before. May as well draw a proper dashed center line, long and short dashes through that circular part and continue it down to the bottom, through the flange, a little bit past, that'll do. Now, as we said, that circle was a 20mm diameter, the hole rather was a 20mm diameter. So I'm just going to measure out 10mm either side, and then I can throw in those two little vertical lines. And remember, hidden detail lines are short dashes. Right, since we're in a center line kind of mood, I will put in a center line through, a horizontal center line through this circle here. And through this circle. Alright, I'll leave that view as it is for now, and we'll start doing the left end view. Alright, continue with the left end view. Now I'll just come over some arbitrary distance between the views. Distance doesn't matter, I'm going about, I don't know, 15mm or so there. Now the width of this part, looking from the left end as we worked out before, was going to be, oh, we haven't worked that out yet. Let's have a look. We've got, it's 63mm, no calculation to be done. So at the 63mm mark, I'm just going to put a little mark and a vertical line. Okay, so that rectangular box that you may or may not be able to see there is going to be the confines, or the outer extents, the extremities of the left end view. Now, we're going to be looking at it in this direction here, and it's going to be sectioned along that line there, which is this plane here. Now, just to help us out a little bit, I'm going to project that center line right up there, because this point here is where we're going to draw, this point here is where the part is going to be sectioned. Probably not a bad time actually to draw in the section plane. So just going to put a little mark in here and here. Don't mind the baby noise. Draw in a little horizontal leader here and here with some arrows. and I'll indicate that this is section plane B. That's where that the section plane that is going to be visible in this view is taken from. Okay, so there's going to be a few details that we're going to have to project across from this front view, including the inside diameter of that bore and the outside diameter of that circular feature, I suppose a spigot you would call it. So that's 75 millimeters up. The difference in those radii should be 12.5 millimeters. I'll do the same thing top and bottom. Now I can draw in these lines. Now I'm going to go ahead and firm this line in here right from the outset, because just by thinking about it I can tell that it goes the full length of the part, the full width of the part, as does this bottom line here. Okay, another couple of lines I'll project across now. Here and here, so just to clarify, these lines are meeting where those circular features are there on that center line. The next one I'm going to project across is where this 65 millimeter radius arc intersects with that section plane. So I'm going to measure the distance that it is down from the top, about 6-ish millimeters. Throw that in here, and now I can project across. See, I have that point there lined up. Alright. The other detail I need to figure out, we need to have shown, is the width of that vertical flange there. And is there any way to work that out? We have the 63 millimeter width here, and we know that this is 47 millimeters, so the remaining width there is 63 minus 47, which is 16 millimeters. So I'll measure across 16 millimeters here. 9-month-old baby singing in the background. And I'll throw in that vertical line there. Okay, now we should be able to firm in most of these details. Hopefully this will make what I've been doing a little bit more clear. Now, it's helpful when you're doing things like this to make sure your eyes are directly above where your pencil is, or especially when you're measuring things, have your eyes directly above your set square. I'm trying to avoid doing that now so the back of my head doesn't fill up the frame of the camera. But it really helps your precision if you keep your eyes above where you're drawing in the exam. And I've made a little mistake here. I should have drawn this as one continuous line all the way through. Okay, so what it will do now is go and draw some of the sectioning lines. So the surfaces that have been sectioned are this area here and this area here, which is the equivalent of the bottom half and the top half of that spigot, and then this section of this vertical flange. Now to do that, I've got a 45 degree set square, and I actually have a line scribed in from the edge, a short distance, 4 millimeters from the edge of that set square. I think technically section lines should be a bit closer than that, but having them 4 millimeters apart speeds up the process. You don't end up doing so many of them. Right, that's the cross-hatching for the sectioning done, and there's just a few more details we have to add to this view. So we have to show the hidden detail that represents what we would see looking at the inside surface of this bore from the things that are behind it. So that would be the upper and lower surface of this flange and the edges of this hole. So let's also a segment of this vertical flange that you would see looking through that object. So it's pretty easy to do using the lines we've already drawn. Got some hidden detail here. Remember, hidden detail lines are short dashed lines. Right, let's just work out the positioning of this hole. We can see that it is 25 millimeters from that outer edge, as shown by the fact that radius there is 25 millimeters, and it is a 20 millimeter diameter hole. So to find its center, I'll just come in 25 millimeters from that edge, put a mark, and I will drop in a center line through that mark. Long short dashes, and we can just measure out 10 millimeters either side and drop those hidden detail lines in. Alright, so that's all the hidden detail finished there. So the only things to do now are to throw in a few dimensions, and then we're basically done. So let's just do one of each type of dimension, or each of the common types of dimension, to prove that we can. The HSC exams will often tell you exactly what they want, and usually the goal is to show that you know how to produce dimensions. Our little dimension lines there. Remember, the dimension lines are medium weight. They don't touch the part. There's usually about a 1 or 2 millimeter gap. Your little arrowheads, and your dimension itself should be written so that it sits on top of that dimension line, not underneath it. So there's a horizontal dimension. Let's do a radius now. So let's do this 65 millimeter radius. So from the center point where we originally drew it, I will put in our dimension line, do our arrowhead, do our leader. The leader is meant to be a horizontal line, and we'll draw in, or write in, the actual distance. Quality of your lettering should be a bit better than that if you can. Alright, so that's that radius drawn in. Let's do a diameter now. It's pretty much the same process. Remember your arrowheads. We'll do a horizontal line for the leader. And then we'll write in the diameter of this feature. In this case, it is 22 millimeters. Alright, and draw a vertical dimension in. Now, a bit awkward doing this on the left-hand end of the object, but if I try to do it on the right-hand side, I will knock over my camera tripod. Anyway. Dimensions should be drawn so that they're read in the vertical position or by turning to the left. When you're doing this, turn your page around so you can write upright, don't turn your body around like I just did, and you'll get better quality lettering. The last thing to do would be to label the views. So you should draw yourself some guidelines for your lettering that would be normally about 4 millimeters apart. Your lettering should be capitals. Now this one is a sectioned left end view BB. Now anyone who knows anything about technical drawing will be screaming that I haven't got a border or a title block here, but fortunately this is just for a HSC exam where we don't care about things like that. But that is that drawing basically complete.